Hey everybody, it's Andrew here. Welcome, if this is your first time to the show, welcome to Hydroponics and Indoor Growing. If this is your, fifth time we've done this, I guess, or sixth time we've done this, I think. I've lost count already, so there you go. Then welcome back. Thank you for coming back. Tonight is something a little different. I've never done this before. Actually, certainly never done this on camera. Sounds intriguing. I was thinking this past week about how I've had a soldering iron in my hand since I was about 11 years old, and because I was that kid. And it occurred to me that that's not true for most people. Most people probably aren't everyday users of such things like soldering irons. And I thought about how often I use kind of weird tools in developing hydroponic systems. And I thought about how maybe some of these things that I do on a daily basis might be useful to all of you. And then I thought, well, which skills would be the most used? And it's going to be what we cover tonight. It's just a little bit of soldering, a little bit of wiring, not really much to it. I mean, it's low voltage, it's 12 volts. The tools are very common and the techniques are very simple. And I'll show you a few things tonight. I'll just free speak as I do this. And I'm going to be assembling actually a controller tonight. So this is eventually will be a customer unit, which reminds me, I wanted to tell you this story. Okay. So a few weeks ago, I had a video about DIY aeroponic systems, right? And I showed the unit with it was kind of like this, but it had the longer body. So I wanted to be able to show a link that goes to a page where the product would be eventually for sale. So I created the link, I built the page, and I linked to it in the video. And I didn't at all think that anybody was going to order this. Well, lo and behold, not only was there an order placed, there were several orders placed, which was amazing, but it kind of, it made me think, well, maybe I need to get rolling on this a little quicker. Maybe I need to get these out to market. They were originally supposed to come out on July 15th, but a couple weeks ago when the orders came through, I said, I'm going to get a jump on this and start it. And as I was building these controllers, which I'm just finishing up now. So by the way, Avi, if you're watching, Wilson and Jerome, if you are out there, I'm about to go over to YouTube in a second to check out if you're there and chatting tonight. But this controller that we're building tonight is actually going to be either Wilson's or Jerome's. I'm not sure who's going to get this one, but it'll be one of the two that's built right now. I have another one over here that is complete. That is going to, well, again, either Wilson or Jerome, but this one and the one we're building tonight are the two that are going out next, okay? So the reason I'm doing this is because the whole idea of this as a DIY project is that I want to close the loop. You can either look at what I'm doing, download the STI files and 3D print your own case, order the parts on Alibaba, use your soldering iron and assemble it and do the whole thing yourself. Or you can order a kit, either a partial kit or a complete kit. Partial kit, and it all depends on your comfort level. I mean, some people don't want to pick up a soldering iron, which is totally understandable. I get it. There are certain tools and certain things that you do in this kind of work that aren't for everybody, of course. So for those people, I have the kit available so that all of the parts, all the bits and pieces, the timers and the pumps and the 3D printed case and the wires and everything you need basically is there. So you don't have to order it, you don't have to find it and all of that. It's all put together. And for those who just want the whole thing already assembled, that is already an option where it comes with the buckets, everything's already built. More or less, there's just a small bit of assembly required. But basically, the kit that's available right now is almost complete. It's almost fully assembled when you get it. All you do is just you put the tubes into the buckets and you hang up the controller, you plug the tubes into that, plug it into the wall, and you're done. But tonight we're going to build the controller that goes into those kits, and we're going to do it using the exact parts that are used in that kit. So I'm going to go over to Skycam, and we're going to check this out really in hopefully very high resolution, because this is the Skycam tonight is the iPhone itself, and the resolution is very high on that. So it should be very clear, but if it's not, I want you to let me know, but I have tested it. So it should be okay. And this is the view that we have. How does that look? I'm going to go over to YouTube's. Somebody tell me how that looks. Yeah, how's it look? All right, you can let me know as I go. So here's what we're going to do. When I start with these, they come off of the printer and they are kind of stringy like that. You can see these little hairs coming off of here, right? That is because that's the nature of the material that I use, that I print in. It's called PETG, and it gets a little stringy. It's a higher temperature material, and it's a very durable, very high strength material. But it does tend to get a little stringy, a little gooey like that. So what I do is I take a little, it's kind of like it's like a hair dryer. It's like a mini hair dryer. And I use this for heat shrink tubing, and I also use it for a variety of things, heat shrink tubing and other things. But it's great for this. And what I do is I get all the big stuff off of here. And so for you 3D printer people out there, you'll just appreciate these little things I'll be talking about, I guess. And then I use this to clean it up. Just like that. And the heat just basically shrivels up the little bits and pieces. You can even just kind of rub them away with your finger after a second or two. Heat it up. Because remember, these materials are thermoplastics, right? So if you introduce a little bit of heated air, you can do wonders with those little hairs. Smoothing out a few edges here and there, cleaning it up a bit, making it nice. That's what we want. We want it to be nice and smooth. With that, that's just about good. Just gonna, a few extra hairs I spotted there. All right. Yeah, like that. Good, that's pretty good. It's good. Saw a few spider web looking things in the hole there. Oh, I see one hanging on there. Where is it? There it is. I got you. We got him, didn't we? All right. So there we go. Nice and cleaned up and ready to rock and roll. This is the panel you recognize from a complete one here. There you go. So that's what it looks like before I put the decal on. Now, I'm not going to be putting on the decal on this one tonight on the show because that's pretty involved, and I need to do that in a very clean, dust-free area. And clean and dust-free, this area is not. So I'm not going to do the decal part. But as you can see, it's very smooth, ready to go. And there are two parts here. There's this bottom part, and then, of course, the top part, which, oops, let's clean that up really quickly, too. It's got a few hairs on there. Show you a little closer here so you can see those hairs we're about to clean up. As I hold the heat on it, whoop, they just go away. Sometimes you got to change your angle a little bit to get it to completely go away. But then, and while it's warm, you can just kind of wipe it smooth. Make sure you don't get any little, I call them boogers, in case you don't get any little small boogers on there. You don't want any boogers on your pieces, on your parts. No boogers. This is a booger-free zone. How many times can I say booger in this video, I wonder? There we go. All right. Looking good. Looking good in the neighborhood. All right. Excellent. Okay, good. Nice and cleaned up. Now you will notice that this part is keyed. What do I mean by that? It means that this top part and this bottom part can only go together one way. One way only. The key is right there. As you can see, it's a little bump right there. And that makes it so that it's not possible to do it backwards. There actually technically would not be a backwards, but I use keying in a lot of designs, and it's a good idea because it secures it and it makes it error-free for sure. Okay, and the thumb screw is, by the way, I'll show this to you really quickly. If you do let's try that again from the start. If you do 3D print your own parts, you can opt to turn the hole that's designed into the file. You can turn that into a threaded hole using a threaded tap, which I get these on Amazon. And it has a drill bit on the end of it there, and then that drill bit turns into a tap, just in a very gradual way. And you just put it on the end of your drill, and then you gently, and I'll show you that in a minute, you put it on your drill, and then you go in with it, and then you come out with it, and sometimes you have to clean it up once or twice, go in and out. And then you can fit parts like this. This is an M5, that's metric, it means 5 millimeter. M6 would be 6 millimeter, M7 would be 7 millimeter, and so forth. And that just fits in there like that, boom. That's why they're so great to use with 3D printed parts. So, tip there for 3D printers out there. Okie dokie, now I'm going to loosen that up. Pop that on the top there just to show you how that tightens down. There you go, Bob's your uncle. Ready to go. So, step one, we're going to take a look at putting our timers, how they fit in here. They go in just like that. Now we're going to wire them in a second. I'm just showing you how they actually insert there, just like that. And then there is the power outlet, which is a 6.1 millimeter outlet, which is very common size for 12 volt power adapters here in the United States. The ones you get from most of your products are 6.1 millimeter, just like this one will accept. So it looks just like that. Popped it into the hole there, and then has a little washer there. And then it has the lock nut. Now I order a lot of these at a time because I'm assembling kits for people, so that's why the bag is so big. You can order smaller quantities of these on Alibaba, although honestly, sometimes the quantities are pretty huge. Even the small quantities are pretty enormous on either Aliexpress for sure, but certainly on Alibaba, but definitely also on Aliexpress once in a while. Those minimum quantities are like 100 minimum. It's like, wait, I need one. Can't I just get 10? No, you have to get 100. Okay. So now we have all of the components that function, well, almost. Okay, sorry about that. We have all the components mounted in the main chassis. So now that we have those sitting there, let's take a little gander, if you will, at what's going on here in the wiring. It's very straightforward, but if you've never seen it before, it looks a little weird, right? But these are very typical of the wiring that you'll get on a digital timer. There's simply there's a positive and a negative. That's for your positive 12 volts, positive and negative. And then there is the switch 1 and switch 2. Now, here's the interesting thing. They're different ways of wiring these so that they do different things. For us, we have the simplest application, as a matter of fact. All we're going to do is we're going to accept the power into this timer, and then we're going to pass on the negative pole over to our switch, and then that's going to be what gets switched when the timer turns on. And then when the timer turns on, it passes that power from switch 1 to switch 2 and powers our pump, this little dude here. So once again, the power comes in, we pass the negative terminal over to S1, and then we hook our pump negative to S2 and the pump positive to the positive. And then when the pump turns on, it's passing the negative pole, closing that terminal, and passing that negative pole electricity through to the negative pole of the pump. And the positive pole is already hooked up. And then when the pump turns off, then it disconnects these two terminals and it turns off the pump. right? It's as simple as that. It is really very, very simple. And it shows in the diagram here that little switch action. That's what a switch looks like in schematics. And that's how that works. And your load is actually spelled L-A-O-D on this. Is pretty funny. But it's load is what they meant to spell here. And that's what's hooked up right here to S1 and S2. That's the pump. Pump is the load, right? So inside of here, let's see if we can pop this off without causing too much catastrophe on camera here. Actually, normally, well, I don't normally do this in the chassis. I was going to do this on camera, but normally I have it out like this, and I will very gently pry away like that. Use my fingernail to just, whoop, that's it. Pull it off like that. And then inside here, you can see there is the goings on, the business end of the timer. There are a few integrated circuits right down in here. You can see that. A few integrated circuits, ICs, and then a few other components. There's transistor, a few other things going on in there. Not a whole heck of a lot. It's been condensed into these few little components. And then this big guy here, this big boxy looking thing, see that from an angle, this big black box. That's the heart and soul of the whole thing. That's a relay. That's an electric relay. So what happens is when the timer does its thing, it's actually triggering this relay, which is closing the switch. That's how, in electronics, that's how you create a mechanical type switch for an electronic circuit, is through a relay, especially when you need to change the power dramatically from one state to another. You use a relay. So, but don't need to get too far into that. I just wanted to point these out and show you what's going on inside there and how easy they are to take apart and to see what's going on. So there you go. That pops back on there like that. So now what we have here is we have our terminal block, which is 4 terminals. Again, we have, take a closer look at that. We have our positive, our negative, passing a negative on to S1. S1 and S2 is our switch. And then we have our terminal block. Our terminal block are just tiny little screws that you can use a screwdriver like this. This happens to be a, the heck is this? 2mm flathead screwdriver. It's actually a Phillips style. Well, sort of. That's kind of a hybrid style, these screws. But flathead works fine as long as it's a good one and it's nice and sharp. You get in there and you can just loosen and tighten these. But I'm going to tell you a trick about these components, though. These 12-volt components are made to fit teeny little wires. And the wires that at least I tend to use tend to be a slightly larger gauge. So I'm going to show you what to do if you have larger gauge wires, which you probably do, and how to get them to fit in here even if you have larger gauge wires, so that that's not the thing that stops you. So it's a little trick. So I will show you that. And it's actually something I use when building these because you have to. There's no other way around it, actually. So we'll look at that in a sec. And let's see, what's the best way to show? Okay. The pumps and motors are connected together using these micro connectors. And these you've probably seen if you've ever opened up modern electronics, DVD players and whatever, what have you, those kinds of things. You probably have seen these little micro connectors here before. They're all over the place. And that's what's used inside here. That's what I use. And they just plug together like that. They can they're keyed also, just like this is. So this idea is not just mine, obviously. It's all over the place. It's keyed, so you can only put it together one way. Just like that. And that's what we're going to use to connect our components together inside the chassis here. Okay? Alrighty then. The first step is I want to show you that the wire, well, the 3D chassis, the design of this is designed to accept the wire through the middle, ultimately, so that when this gets placed back down, it's not pinching the wire anywhere. So on here, there's a hole designed into it that accepts the wire through it. Okay, so you're always feeding your wires through there, and it's designed so that they will not get pinched. Everything has plenty of space to do its thing, while also being as compact as possible. I did my very best to keep it as small and compact as possible. So what we're going to do is remember that the pumps are going in like this, and the wires are there, so we don't want to crush our connector. We want to make sure that when we put our pumps in, the connector is clear from that when we put the pump in, okay? But the pumps are pressure fit. They just pop in and out. Very simple to do. And we want the in to be on the, I'll show you that part in a second. Anyway, want the wires to be in like that. So we take this off, and we'll just trim a bit of this wire off to keep it clean, because what we don't want to do is we don't want to have a whole bunch of extra wire in there floating around and causing problems. So I trimmed about maybe 2 inches off of that. Now I'm just going to clean the end off here. I'm stripping, I'm sorry, not cleaning the end, I'm stripping the wire here. And use the right terminology here. I don't want to confuse you. All right. Just like that. And then and some of this is just basic stuff, but I'm just going through the whole process because, hey, maybe you've never seen it before. I don't know what you've seen or what you haven't seen. So, and I just twist the wires. So, and what am I doing? I'm just taking the wire in one hand, and then literally I'm doing that. I'm twisting the wire itself, and I'm really kind of holding the wire still. And then I'll twist it back, just like that, just like that. I'm overdoing it for camera, but yeah, just showing you the motion, just like that. That's it. Then a little trick here. I bring over my rosin. I don't know how familiar you are with soldering, but in soldering, the rosin paste, that's what you want, the good stuff. It's golden like honey. Oh, very sticky too. The rosin helps the solder to flow onto the joint, and it also protects it from oxidation, from oxidizing, from burning, from the heat, from the iron. So it's pretty important stuff to use, and you don't need a lot. A little goes a long way. But one thing I like to do is when I'm starting to do a soldering job on a whole bunch of wiring, I'll go ahead and I'll create a little soft pool out of the flux here because it's heat sensitive. It'll melt if you introduce the heat to it. And then, one second, I'll create the pool, and then every time I have a wire to solder, I'll just dip it into that pool, and then I'm ready to solder it. So, bring the soldering iron over, create my little pool, just like that. Boom, boom, boom. Dip it, boom, done. Then I come over with my solder. And normally I have these things called helping hands, which hold everything for me to do, but I can do this without the helping hands, no problem. I take it, hope you can see this. I'm just creating a little blob to begin because I'm just trying to, whoops, didn't mean to do that actually. That was a little more than I needed. I'm heating up the wire itself, and then the solder is to flow on the wire. You're not heating the solder necessarily, you're heating the wire. And then you're letting the solder flow onto the wire. I can barely see this. My apologies. I'm doing the best I can on camera here. To clean this one on. Come on. Let me retin this tip. There we go. Okay, now we're good. That's what I want. Okay, and I just tin the tip, just like that. And I don't know if you can see that. I just go with a little bit of solder on the iron and just run it along the wire. Just like, I'm just going to do it again for camera, just run it along the wire. I've got a little blob of solder on the end of the iron, right? And then I've got my exposed wire, and I'm just tinning it. What allows, you see that smoke? That smoke is the rosin. What allows that solder to flow onto the wire is the rosin. Okay, so we tin that. I'm going to grab another one right away. And by the way, these are the female versions of the wire that I use on the timer side, and then on the pump side, I use the male. The male plugs into the timer. If that makes sense. Okay, strip this. that. Okay, a little more off of that. And I have a little fancier pair of wire strippers on hand here, but I actually use those normally during the day. But I figured those are kind of pricey and a little bit out of reach for most people. These are the kind you'll find like in Harbor Freight or, you know, anywhere, Amazon, and kind folks are most likely to get. So I figured that's the one that I would use on camera, no problem. That's the one I had for most of my life, really. I only started using the other ones like, well, it's been maybe 20 years now, but there we go. I'm going to tin these. I still have my pool here, so I just dip into that. It's still nice and soft. Do a little solder on there, yep. And see if I can do this on camera. Let's tin that. Just like that. Just like that. All right. The sound effects are free. All right, then we have the male side. Now, I already went ahead and did one of the pumps. And I'm going to have to figure out for a second here. Yeah, it's going to be the bottom one. Okay, just to save time on camera. So we're going to go ahead and we're going to do the second one. Very simply, I go ahead and I place it into the frame just to make my life easier. It holds everything together. That's its job. Yeah, just like that. Boom. Then we have on the pump, we have, and it's always marked. Every pump I've ever used has been marked with a red dot or a plus sign, but a red dot or a plus sign, and sometimes both, usually both actually. That's the positive, and then there may be nothing on the other side. That just means it's the negative. Or there may be a black dot. Sometimes there's a black dot, not very often. Usually it's simply a red dot. That's to tell you you're positive. All right. So when we go to hook up our plug right here, micro plug, remember that's the male, and then it's going to go into the female like this. This is the way of nature, right? Okay. So we're going to shorten this up. We're going to probably trim another, let's trim another inch off of that. That's about right. Trim another inch, boop, like that. And again, that's just to keep the wires as short as possible because this unit sits against the bucket and we want those wires to tuck in nice and tight so that they don't get snagged or pulled on anything, and they're just always kind of living nice and tight to the chassis. That's what we want. So yeah, again, just twisting those up, boom, 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 like that. All right, tin those up. Like that. Whoops, go into the, that's getting a little, gonna have to loosen that pool up a little bit. There we go. Yeah, that's good. That's good. All right. Clean that soldering iron. Re-tin the soldering iron. Dip into the pool and tin. Tin and tin. Tin and tin. That's it. And ooh, normally I have a rag here to clean my hands. Don't have one. Okay, so zippy-doo. There it is. All right, so we've got one of those done. We need the second one. I'm just going to match it up to make sure they're consistent. There we go. Cut the second one. So again, I don't know. I mean, I don't know how many people have done this sort of thing before or what your skill levels are. You should tell me in the comments what your skill levels are, what you're comfortable with, what you'd like to see done on camera because you'd like to get better at it. Whatever. You got to let me know. Okay, I will try to take on any challenge you give me, even if it's something I've never done before, I promise. And I'll let you know. If it's something I've never done, I'll tell you. Doesn't mean I'm not going to do it. Okay, here we go. Let's twisty on that and give him a dip in the pool real quick. There we go. Ugh, I don't think I'd want to swim in that pool. How about you? Okay, then we're going to tin these. Get some solder on there. Then tinning. Tinning 101. Yeah, tinning is great because what it does is a couple things. It obviously holds together the end of the wire, which makes it much easier to solder to something else. That's the point. And also, it strengthens the wire. That's really important in these little electronics because you need to strengthen the wire at the point where it bends, the point where it's most vulnerable. And the point where it's most vulnerable, of course, is, excuse the cat hair there, is right here where the wire has been stripped from the insulation. Right there is where they tend to break when they break. So if you tin the wire, you're allowing the wire the solder to flow down the wire beyond the insulation, under the insulation, and it strengthens it to the point where the next time there's bare wire without solder, it's inside of the insulated jacket. That's what you want. Okay, that's why we do that. That's one of the reasons we do that. So also, like I said, it makes it easier to, under heat, attach it to something else. Okay, so now we have our bits and pieces for the motors and pumps ready to go. We have one more wire to cut, and I am using from a spool of wire here. This is a 24, I want to tell you correctly, I believe it's 24 gauge. Let me see if I can see it. Is this 24 gauge double power wire, red black double stranded power wire, copper. I don't think this is pure copper, but it's stranded wire. Sorry, let me try to say that entire thing again. It is stranded on the inside, so there are multiple wires inside of here, right? And it is also dual strand. There's a red and a black. I've never had to talk about these things on camera before. It's funny. Okay, so the reason I'm cutting this piece is that it is going to run the power from the power jack here to the farthest timer. So the timer on the top. And that's about a 6-inch piece of wire right there. That's always what it is. I pre-cut these when I build these off camera. Anytime I develop like a production line for something, I standardize everything and then I just cut everything exactly the same. But on camera, yeah, I'm just showing you it's about 6 inches. And here we go. Now, what's nice about this is silicone jacketed wire, which means you can literally, if your nails are strong, you can you can strip that with your nails. Check this out. Just like that. That's how soft it is, that jacket, that silicone jacket. It's just very nice to work with silicone jacketed wire. I really like silicone. And again, with the twisty, this is a little thicker. This is 24 gauge wire, so the twisting action is, I'm like getting a little brutal with it here. Not really, but a little more than the other wire. The other wire is a little thinner. Okay, now we're going to, let's dip into the pool here. Pool's getting a little murky. Going to have to loosen that up in a second. I'll have to call the pool cleaner. Okay, now let's tin this wire. Boom. Now, I know I'm going really fast. You don't have to go this fast. I'm just doing this because of my camera and because it's possible to do that at this point. So let's see, do this side. I'm going to go ahead and do that right away. I usually would not because I would be trimming the wire. Well, let me explain that. Normally what I do when I take a wire like this where I'm about to wire something up and I cut the wire, I tin the one side, but typically I won't tin the other side quite yet because what I want to do typically is I want to solder the one side on permanently and then kind of fine-tune trim the length of the other side before I strip and tin it so that it fits perfectly into the case and I don't have to worry about any slop inside the case. So that's why I would do that. But today for the camera, and I'll fix this later if I have to, but for the customer, but today for the camera, I'm just going to do it right away, like this. And we'll see. It depends how close I come, whether I have to redo it. Okay. So like that, do our twist. Come on, baby. Let's do the twist. All right. Come on, baby. Let's do the twist. All right. Let's just get a blob of solder on there. We go. That's going to take a little more. There's a lot more stranding there. This wire, 24 gauge, a little thicker, so it'll hold more solder, which I kind of like. Okay, also the other thing is, normally when I build these for custom, you know what? I am going to do this for you. I was about to skip the heat shrink, but I'm going to show you the heat shrink because heat shrink's actually really super duper important, especially in wet, humid environments like hydroponics and aeroponics. Because let me tell you about this. Okay, this is actually really important. So, where you tend to have problems, if you're going to have problems in a humid environment or in a grow situation, is anywhere where the electrical components are exposed to the humidity. Like anywhere where you've created a solder joint, or anywhere, like down here where you might tie it into the block. If there's a big piece of wire, bare wire sticking off of there, you might have some problems if it's too large. Anywhere where you have a lot of exposed metal like that, you could potentially get corrosion. You could get oxidation. So what I like to tell people is that anywhere that makes sense to use heat shrink tubing, go ahead and use it. Take the time to use it because it will secure that from the humidity and the environment once you slip it over the joint like that. Let me show you that a little closer. So you would solder that, you would put I'll show you in a second. You'll put cut the heat shrink tubing, place it onto your wire, then solder your wire, then slip the heat shrink tubing over, and then heat shrink it down. And that protects it from the humidity and from every other terrible thing that could happen to it. Also, it gives it, again, a lot of strength. Remember we were talking about that, how the jacket of a wire gives it strength. The heat shrink tubing gives the solder connection strength. That's why you do it. That's one of the reasons you do it. There's always usually more than one reason you do these things. But that is definitely true. So I'll show you how that works in a sec. So we're going to create our little bridge here. Now, since we're passing the power from the negative to S1, we need to create a little wire bridge to bridge these two together, to arc these together. You can use a solid piece of copper wire to do that, but that's pretty hard to come by these days. So I'm going to show you a little trick. To make your own little piece of solid core wire, just take a piece of stranded wire, strip it down there like that, take a single strand of it, cut it. Actually, before you cut it, to make it easier on yourself, what you can do is go ahead and this is silicone, I can strip it with my hands. Go ahead and, watch, I'll fail on camera. I'll be like, oh, I told you I can't strip it anymore. All right, here we go. Then pull that off. Let's see if that'll work. It might not. I might have to actually do it in two pieces. Okay. If it gets like that and it makes you look bad on camera, then, then go ahead and strip off like the last inch of it and then strip off another inch. And then tell everybody, I meant to do that, and then strip off the rest. There you go. Like that. Okay. Now, you got a big hairy mess there, right? You got a big wiry, hairy mess going on there. But here's what's so great about it. In a second, this is going to be awesome. Check this out. Now, you cut it. All right? And you've got a big hairy mess, but it's held together with that, right? Then, you just go like this. Do your twisty again. You're always coming back to the twist. Come on, baby. Let's do the twist. There it is. Boom. All the way down. All the way down. Boom. Look at that. Look at that spear of destiny. Yes. With this, I will rule the kingdom. Okay. So now, take this. Keep it there. Just prop it on there like you meant to do that. Yep. Now what we're going to do, this is so much fun. Now what we're going to do is we're going to tin that whole thing. And we're going to turn it into a solid piece of wire. Now, the thing is, usually, like I said, I usually have my helping hands here to hold it down. However, whoops, these are pretty heavy. I think this pair of pliers might work. Yeah, that should work okay. All right. All right, now heat up the let's do it from the, yeah, you know what, let's do it this way. I'm gonna heat up the wire, and then I'm just gonna move from left to right, and I'm just gonna heat and let the solder flow into the wire the entire length. Just like that, and then take a swipe back to even it out if there are any large unruly blobs like that. Boom, done. Check this out. Don't touch it right away or you'll be screaming like a little girl. Okay, there you go. Your spear of destiny is now ready for battle. This sucker is nice, and it's bendy, but it's a single piece. It's very, you know, I don't know how to prove that until I show how it solders, but yeah, it's solid. It's like a single wire. So what I'm going to do is I'm going to trim off about as much as I need here. I'm going to trim the end first, and then I'm going to trim off a piece about the right size here, about like that. It's about maybe 3/4 of an inch. And then I'm going to use a small pair of pliers, and I'm going to create a, oops, sorry, bring it up here. Then I'm going to create a U shape, like that, just like that. And that's what you're going to use to bridge. I'll bring this up here to show you. To bridge the two terminals in the middle, right? That's what you want to do, because you want to pass the negative onto S1. Oops, I need to squeeze these a little bit. Squeeze them together a little bit. There we go. Now you should be able to, there you go. Now you can push that right in there, and it does fit a single wire like that, but you're not getting anything else in there. You're getting that in there, which is totally fine, because now you can solder anything you want to that, right? Piece of cake. So while it's in there, I'm just going to go ahead and tighten that down. Give it a couple turns. You'll feel when it's all the way. And, oh, well, let me show you. And there you go. There it is, ready to go, right? Let me do the same thing to the other one. Cut off a piece here. Where did they go? Yeah, there we go. Like that. Create your U shape. That's your bridge. Just like that. Make them as even as you can. Don't have to go too crazy. Make sure your screws are loosened before you do this, or you'll just be jamming it in and bending it. Make sure they're loose, because you can't tell from here. You can't tell if they're open or not. It's crazy. The gap is so small. Pushes right in there. Boom. And then where'd my screwdriver? There it is. And then you can tighten that down. The other side. Now, remember, your power is going to go into the first two, positive and negative. Then we're going to take, I just did that wrong. No, I didn't. No, that's right. No, sorry. Okay. It looked straight. Yeah, I can't see very well. Okay, no, that's right. Okay, so your positive and negative goes in here, and then we pass the negative onto the switch, which we did with the little bridge, and then we're going to put our positive from our lead to our pump, our positive to our pump, right there, okay? Or, I said that wrong too. The negative to the pump, sorry. Positive just goes directly to positive, gets hardwired directly to positive. Okay, so we're going to go take the male, which is, where did I put them? Over here. Okay. And I'm going to put the positive right into S2. Just like that, right? And then the negative will be soldered onto that little U-shaped bridge that we created. So that's going to be tough to show on camera, but let me see here. How can I do this best for you? Yeah, well, I think you can sort of see what I'm doing there. So, and I want to keep the amount of exposed wire to a minimum, so I'll trim that so it's much, much shorter. And I may do a resolder here in a second because, like I said, I normally use heat shrink tubing, but I can't go through all that on camera. It would take too long. But it might mean I have to solder this in a different way to show you a way to do it even without the heat shrink. I'm trying to figure out how to show that. Okay. So anyway, all I did was I just soldered the soldered the negative onto the bridge, and now I'm just going to take the power wire, which was the 6-inch piece that we cut. If I could find it, there it is. And now I put the positive into the power positive for the timer. Just like that, right there, and then the negative. Now, there may be room, you can squish it in there, or you may have to solder it. It depends. Sometimes these timers are just big enough that you can squeeze the two wires side by side in there, and sometimes they're not. We'll try it. Yes, that's fine. That'll work just fine. And then tighten it down. So now you've got your negative power wire and your little bridge together in that second terminal spot. And we think here, is that it? Yes, that is. Is that it? No, sorry. Let me just fix this up a little bit. I gotta take this out because that's supposed to go. Alright, let me just fix this and then I'm going to show you. I kind of made an error there on camera. I don't want to confuse you, so I'm just going to fix it. And then we're going to talk about it. Now I'm going to put, okay. Alright. Okay, so what happens here? In the end, this is, yeah, it's easier if I just go ahead and do it and then I'll talk about it. Okay, so in the end, what you want is you want your positive connected all the time for your pump to the positive terminal along with your positive coming in. Your negative again gets passed over here, and then when this pump turns on, it passes the negative over to the pump, which is the final one on the terminal block. So I did make a little mistake on camera there. I apologize, but in the end, this is the wiring you want. So negative to terminal 4, positive to first terminal, power in on the first and second is passed to the third. That's it. Boom. We're going to do the same thing on the other timer. Except for the power, we're going to do last because we need to get it into the chassis before we do the final wiring. Okay, so we have the male. Again, we are putting the negative into position 4, trim a little off of there. Oh, and another thing I like to do with these super thin wires to make them more, to be able to clamp down on them with the screw, is put a little blob of solder on the end of these tiny, tiny thin wires, because that gives it some meat. It gives it something for the screw to dig into. Just like that. Just blob onto the end of these a little bit, you know. Give it a little mass. Yeah, because these are so thin that they have trouble even being screwed down tightly. So, okay. Let's just go ahead and hook this up before I make a mistake on camera again. All right, so the negative goes in the end here. That's all right. We'll get this done. Okay, in the end. Oh, see? It's so freaking thin. I can't even. Okay, no problem. Here's what we do. If the wire, well, we're going to try, you know what? We're going to try once more with a blob because I don't want to take any more time if I don't have to. But there's another trick I was going to show you. There we go. I think I might get away with this today, though. Yep, that might work for camera anyway. We'll see. That's good, but we'll see. I don't know. If I can't bite down on it, I'll show you the trick. Okay, screw all the way down. Is it biting? It's not. Pulls right out. Okay. So now what I'm going to do is I'm going to take a little bit of that wire that we made earlier, that stiffened up wire. If I can find it now, it's camouflage. There we go. All right, here it is. I'm going to take a little piece of that, just a bit, maybe ½ inch. And we're just going to put that right into position 4, if I can grab it there. Position 4, yep. Okay, so we've got that plugged into position 4. You can see it there. I'm going to solder to it right now. I hardly even have to tighten this now. It's so tight. Of course I will, but yeah, wow. That was nice. That went in really nicely. Okay, so there we go. There's that. Then we're just going to go and solder the negative male terminal that's going to lead to the pump onto here. And once again, I want to keep saying it. Normally I'd have a heat shrink tube. Well, let me show that while I'm here. Since I was going to show you heat shrink tubing anyway, I'll show you one piece. How about that? Let me detach that so I can do it again. Okay. So here's what happens. You take your heat shrink tubing, which should be just big enough to fit over whatever wire you're trying to cover. Just big enough to kind of safely protect it with a little wiggle room, just enough wiggle room that you can shrink down on it. All right. And then cut off a piece that's big enough to fit over the junction of the wire, but not so big that it gets in your way. All right, so slide that over the black, and it's about, I don't know, ½ inch or something like that, just like that, right? Now you go ahead, slide that out, let it fall down to the bottom. Go ahead and solder your connection. Just like that. Now, slide the heat shrink collar over top of the joint. Just like that, right? Now, see if I can do this on camera without melting anything. Grab your heat gun. And carefully, without melting the device, shrink the tubing. In fact, use your hand as a guide so you don't burn anything. Just, you can feel the heat. Just like that, right? And then, before it gets too cool, go ahead and bend it down a little bit. Just kind of flatten it a bit, just like that. That'll make it kind of stay in place a little easier, right? Then, so that's all sorted. Yeah, that's great. And then you have your positive. You know what? I'm going to go ahead and do the same thing. I'm going to go ahead and cut a little piece here. We're going to use that for a positive. We're going to send that right in here. Yep. And then tighten down on that. Then we're going to go ahead and we're going to hold off on soldering that because, like I said, you want to put all this in the cabinet before we do that. We're almost ready to do that. So let's pop this bad boy into the cabinet. Just like this. Now, you want to be careful. You don't want to pinch off your wires while you're doing this, okay? So just be careful. Just kind of guide them gently over to the side, you know. Be cool, be cool. Let's see. Whoops. Actually, they need to go this way. They need to go under. Just like that. And then, boop, pop it back into place like that. Done. And then go ahead and pop the bottom one in. And the rest we can do with the unit half assembled like this. Oops. See, I pinched a wire because I wasn't paying attention. There you go. It happens. Oops. Keep that. There we go. All right. Come on. Pinch the wire again. Come on. Play nice with the other kids. Come on. Wow. It's so much harder to do this on camera. That's crazy. All right. There we go. Okay, so that's been sorted. Bob's your uncle. Now, what do we have? We have, remember, this is designed so that, sorry, let me clean up here a little bit. This is designed so that the wires can be fed underneath the pump holder. Okay, there's a channel under here to allow the wires to run under it. All right, so the top pump wire gets fed to the middle, and then the one on the bottom gets fed to the middle, and they both go up through the middle like that and like that, and we're going to leave that right there. You know what? I'm going to put nope, we're going to roll with it. All right, and I'm going to slide that in there just like that. There we go. Now what we're going to do is we're going to hook the wire to the pump, which we have not done yet. So we're going to take this guy here. All right. And we only need a really bitty short one here because we just need the round around the corner, so to speak, and that only takes like an inch. So if you see that, let me bring this up to the camera for you here. I'm going to tighten this down so it doesn't all fall apart. There we go. All right, so I bring this up to camera. All we need is a little short one here. So what I like to do is I go ahead and I connect it first. Just go ahead and plug it together. And then you kind of can, it's easier to see. Oops, why can't I see tonight? This is great. There we go. All right. All right, so then you can see that you really don't need that much. You know, you only need like maybe an inch of wire there, right? And then it keeps it nice and tucked, nice and close to the body. So the shorter the wire is, the tighter it'll tuck to the motor, and that's what you want. You want to keep it close. You just want it enough that you can disconnect it if you have to. Okay, and so I'll do the red first, just one at a time, so you can custom cut each one. Just like that. Okay, and then I kept that really short, that the amount of exposed wire there, because I only need a tiny bit here. And I did pre-tin this pump, so I'm going to go ahead, and normally I would do heat shrink on this, but I'm not going to do it just for the camera. I'll have to go back and do it later. But I'll solder it for you here, and remember, if you were doing heat, whoops, my soldering iron always wants to turn off automatically. So, well, and it'll give me a few moments to talk then while the soldering iron is heating up. So again, if you were to do the heat shrink tubing here, oh, what the heck, let's just do it. All right, just cut the piece about a ½ inch, slide it over the red. And now that the soldering iron is just about hot enough, we'll go ahead and solder this terminal, and well, I want to be on this side actually. Awkward on camera. Okay. Okay, I don't know how much of that you can even see. Let me pull it this way. Okay. Okay, I'm just going to solder this like this so you can see this. Okay, so I'm just taking this wire and I'm just going to solder it to the positive terminal on the pump. I think you can see this. I hope you can. If I can find it. I can't see it. Okay, there we go. Yep. And not quite. There we go. Let that cool. I introduced a lot of heat there. Okay, yeah, we're good. All right, so there we go. And then the negative, let's just go ahead. Yeah, I didn't do the heat shrink. I know. You can tell me about it later. I'm fighting the clock here, guys. I'm sorry. I'm trying to keep this under an hour, but I didn't quite make it. Sorry about that. All right. So let's do the twisty, and I'll go ahead and solder that one. Yeah, I do try to keep these shows under an hour. I know everybody's got other things to do. I do appreciate that, and I appreciate you being here. I don't want to waste your time or make you feel as if I have, certainly. Okay. Oops. Okay, we're good. Yeah, so like I said, I'm not going to do that. Heat shrink takes too much time. I'll do that later. But so there we go. And now what we do is take the second pump, which actually, conveniently, I already connected a connector to that one, so we'll be okay there. And what I'm going to do is I'm going to take my other male connector there. Oh, you know what? I may have to, I'm sorry. I may have to redo this pump is wired differently than the others. Shoot and holler. Okay. I'm going to cut this off real quick. I don't think I have another pump. You know what? In 2 seconds, I might have another pump here I can just use. That would be better. Yeah. Oh, yes. Right. Well, no, that's all soldered up as well. Okay. So I'm going to have to, what am I going to do here? I am going to take this apart real quick and resolder it with the connector we need. And I'll do that on camera so I can show you this. Do apologize. I was not expecting that to be this. What happened here? This was from an earlier wiring pattern that I had for these, and I don't wire it the same way anymore. I figured out a better way, but just redo this real quick for you. All right, there we go. That wasn't so terrible. All right, let's take this off. All right. There we go. Okay. So I'm going to grab a connector here, and we are going to connect that using that keyed micro connector. Plug in the pump. And that's satisfying. When you pop that in, I want to hear that again. Here we go. Ready, ready, ready. Awesome. I love that. It never gets old. All right. Then we're going to, there we go, custom trim that right about there. Sorry, I'm going as fast as I can here without nipping the ends of my fingers off. All right, or burning the house down or some other terrible thing. All right, solder this one. Oops. And the other thing I normally would do is what I showed you earlier. I'd be dipping into the pool to make it easier to solder, but these things all take time, so. Yeah. So something I want to show you here real quick. Sometimes what happens is on these connectors, like the pump connectors, they get a little corroded, especially if you go to do a repair. So what I'm going to do, I'm going to scrape it a little bit. I'm just going to clean up that copper a little bit because it makes it hard to solder onto it. There we go. That should help. And then you try it again because you kind of need clean metal. You need clean metal to solder. You need clean metal to weld, generally speaking. Anytime you're working with metal like that, you need it to be clean, or heat just won't do what it's supposed to do. So, yeah, okay. There we go. That's better. There we go. That's like 1,000% better. All right, we got our positive. Now we're going to go for a negative. I'm going to custom cut. Like so. Like so. I think I got that from my grandmother about 1 million years ago. Okay. Like so. Just do it like so. Do it like your granny does it. Do it like so. Okay, here we go. Bam, is this really soldered? I don't believe you. Oops, that hurt. Like a lot. Wow, I'm going to remember that for at least 10 more seconds. Okay. Come on. Why is this one giving me so much issue? Wow. Dude, what is happening here? All right, give me a moment. I need to have a face-to-face with my pump here. All right, now we're getting serious. I need to superheat this. There we go. We need to retin that. Come on now. There we go. Now be a good boy and behave for the camera. There we go. All right. There we go. There we go. There we go. We got it. All right. So we're almost there, believe it or not. Okay, so all we need to do now is, actually, I am going to cut this a little shorter. No, I'm not. Okay, I was going to custom cut it. I'm going to do that later. Now we just need to run a little jumper. I call it a jumper. I believe the technical term is jumper, but to bridge the positive terminal of the power in over to the first timer, because this long wire, this 6-inch long wire, remember, that's just connecting the power all the way over to the farthest timer, right? So we need to connect to our first timer, which is the one right next to where the power comes in, and that's what we're going to do now. So I'm just attaching a wire to that jumper, a jumper to the jumper, two jumpers jumping together. That sounds like an interesting arrangement. And then we're going to solder those together, and then we're going to trim them just like so, like Granny does it. There we go. And then we're just going to trim that like so. And then we've got the positive from the pump, which is going to go onto the rest of the positives. We got a bunch of positives meeting here. Positive to the first pump, positive to the second pump, positive from the power in, and the positive to I lost track. All right, here we go. Now remember, I had that little jumper wire, so all I'm doing is I'm soldering right to the jumper wire, or the extension wire that I put in there. Yeah, what do you call these things? I don't know what I've never had to talk about these things before. I'm not sure what to call some of these things. Yeah. Okay, now I'm just hooking the pump positive wire onto the main positive connector. And then we plug the connector back on. Actually, you know what? I'm going to take that peg out and try to wire directly into it, because I don't think that's going to hold. I don't think I have enough meat there to do. Yeah. Maybe if I make it a little, well, let's see here. Let's see if I can go directly in there. Nope. Okay, we do need a peg, so I'm going to cut a new one. Okay. I'm going to put that right in there. Boom, that's better. Okay, all I did was I put a longer, extension wire there in that first positive terminal, so that I have something to solder to, because there was nothing there. So normally, just so you know, normally what I use is solid copper wire. And I just put it on all of the terminal blocks, and one for each. And that's the best way to do it, because then you've got something to work with. You have a little bit you can solder to. You can pre-tin it, which makes life so much easier when you can pre-tin. And yeah, that's the way to go, in my opinion. Okay, so but in this case, we're just going to solder to our post here and get this done. Like that. And then we go over and we pre-tin our power input. Boom. And both terminals, the negative and the positive terminal. Positive terminal is always in the middle. Negative terminal is always on the outside casing of a power terminal like this. Let me show you that. Positive terminal is always, see if I can get that here. Positive terminal is always the one. Is that clear? Yeah. Positive terminal is always the one in the middle. And then the outside casing is always the negative. Okay. Hopefully that showed up. All right. And then we'll strip this. This is the positive lead going from the positive power in over to the first pump. Boom, just like that. And now the negative gets attached to the negative terminal of the power in, just like that. I'm going to say it one more time just because I feel like I have to. The customer units that are assembled would always have heat shrink tubing on all of these main connectors. For strength and protection and all the reasons we talked about. There we go. We're actually, yeah, we're done. Hard to believe, but yes, we are. We got through it. You and I got through it together. Okay, so what do we have? We have 2 timers. We have a power outlet, 12 volt in. We have our 2 12 volt pumps on the back. The top timer, which is for the Aeroponics, for the spray cycle, goes to the top pump. And the bottom timer goes to the bottom pump, which is the nutrient recycler, which takes the nutrient solution from the grow chamber and returns it back to the nutrient tank. So we have the 2 pumps, 2 timers hooked up, ready to test. Now, I just discovered one omission I need to take care of super quick. I never did hook up the negative power to the bottom pump. This middle bridge here never got the negative, so I'm going to really quickly solder that on. Now I actually normally would bundle this wire with the other negative wire, but I'm just going to go ahead and solder directly. And oops, if I can, I'll see if I can get away with it tonight. All I'm doing is I'm taking a negative jumper going from the negative power in, 12 volts in, and running it over to the bottom timer, that little jumper wire that we created there, and soldering that in there. That's all I'm doing. And that's what gets switched when the timer turns on and provides the, oh yeah, let me talk about that for a second. So when you're switching one of the wires of a load, you want to switch the negative wire. You don't want to switch the positive wire. It's just bad practice to do that. And it actually goes back to the days when we all worked when people worked with really high voltages, because the positive wire could cause sparking if you try to switch it, whereas the negative wire in those installations would not. It would not create that sparking. So you would always switch your negative wire, and as a habit, I always switch the negative wire. It also creates less wear and tear on your solenoid or your relays, because then your little flapper inside of that relay is not creating sparks every time it goes to close. So you want to switch your negative. Always switch your negatives. Don't switch your positives. That's a mistake that many people make. They try to switch the positive. Don't do it. Don't do it, sonny boy. Okay, so let's just solder that if I can get it. There we go. There we go. Even without glasses. Okay. got that one started. Now, theoretically, we should be good to go. Looks good to me. So far, so good. Okay, now let me just grab a power outlet and we'll see what we have. Okay, I've got one off camera here. Gonna plug it into the 12 volts. Whoa! Oh God, this thing's not even paid for yet. All right, get it off of there. Yeah, let me. Whoop. It shot water. I don't know if you saw it on camera. It shot water out when I turned it on. So I had to, and it right onto the computer, no less. So I had to. Oh, jeez. Okay. Yeah, I had to quick do a rescue on the brand new MacBook. All right. So yeah, let me just make sure nobody's gonna drown here. Looks good. Now we do the timers. What we do is we push and hold until it goes into programming mode. P00 is correct. P1 should be P14. So you just use that up arrow to go to P14, and then it's done. And that puts it in, whoops. Stop this one first. P14, P00, P14, P00, P14. Whoops, oh, I went up one too high. Okay, there we go. That explains it. And that means that it's counting in seconds versus minutes. And then when you want to set time, the countdown time, you hit the set one time, and then you go either up or down. Now we're in seconds. So I'll set it for 90 seconds. And then hit the set button again, and that's the amount of time that it'll stay on. So I want to spray for 5 seconds. Boom. Now that's it. So every 90 seconds, the sprayer will turn on for 5 seconds. Then this one is the nutrient return. So I push it once. I want to set that for 120 seconds. This is just arbitrary. These are just numbers I'm making up right now. But every 2 minutes, it'll go in and it will return the nutrient solution. But I only want it to stay on for 10 seconds because I know it doesn't take that long to return that nutrient solution. So 10 seconds. So every 90 seconds, it'll turn on for 5 seconds and spray the roots. And then every 2 minutes, it'll turn on for 10 seconds and return the nutrient solution to the nutrient tank. And that's how this works. That's how the Hang 10 works. And then the wire that hooks on the back here. Now, I didn't drill the holes for it, but the holes are part of the design. They're actually in the print, as you can see here on the top here. But they're a little hard to find on camera live. But once they're drilled, then you just place this wire right into the holes. Oh, let me see if I can do it real quickly on camera here, since we're at the end here. And get a small drill bit. I believe this is, yeah, that's the one. Okay. Okay, I'm just going to okay. Now I think that was the right size drill bit. Let's see how close I got. What do you know? That's the one. Okay, and then if I had a bucket here, I do not, but if you had a bucket here, this then would just how do I show it? Just hang on the edge, would hang on the edge of the bucket on the top. And then your hoses would be connected here, and on an actual unit that's being shipped, it would have, see, I'll show you a completed one here. It would have the tubes that are all labeled A, B, C, and D, just like this. And I have them here. If I had time, I was going to go ahead and put those on, but it looks like we are pretty much out of time. So this is what it looks like when it's all done. And again, this is just 2 3D printed parts and then a whole pile of little bits and pieces, just some connectors, pumps, and some timers. Nothing fancy at all. And a power connector, and there you go. So I do hope that this has been super fun, super educational, and hopefully you learned something, and maybe this even inspired you. If it did, please do leave me a like in the comments. And in addition to that, let me know what you would like me to cover. I can cover more things like this, or, obviously we'll be getting back to the growing part pretty soon. But this I wanted to cover because I think this is a really important component if you're an experimenter with aeroponics. And I thought these techniques were important just to kind of get over the fear hump if you've never done it before. And if you have done it before, do some more of it. That's what I say, right? So thank you for joining me. Join me again next week and every Wednesday on hydroponics and indoor growing with Andrew, the Aero-Gro guy. And thank you for being here. And again, like and subscribe. Tell all your friends. Get them on here and go grow something. Let's do this. See you next week.